Hello everyone. Now there should also be sound available in our little stream that we're doing right here. So how is everyone doing? Well, maybe you had already a bit time to join the chat, to make yourself comfortable on your sofa, on your television or whatever, however you are going to join us today. Today the topic of our meetup will be Solid.js, a new framework that I'm going to present to you. But before we're going to start that, let me tell you something about the meetup itself. The way forward is a community of developers working with developers, sharing content, sharing knowledge with other developers, and most importantly for me, having fun together with other professionals. So the fun part is really important for me. Of course, I've prepared some demonstrations for you, but if you have any questions, just feel free to jump in. Type into the chat and let me know what you're interested in, and then we can talk about it. We can adjust our demonstration a bit, we can experiment a bit. So if you have any ideas, if you're curious about how something is working, then just feel free to answer in the chat, and I'm happy to talk about that, and we will be happy to make a little detour in our presentation. Before we start with the presentation, let me introduce you myself. My name is Andreas and I'm from Dresden in Germany. And I'm a development lead or CTO, and I'm not quite sure how you guys want to call it. We don't really do titles at our company. And the goal of our company is to help other software teams to accelerate their software projects. On the one hand, of course, this really means acceleration in the runtime of the application, so performance, but usually it's more about the software development process. But today we are going to focus on the runtime performance, because this is one of the main selling points of Solid.js. I also write about that stuff on Twitter, so feel free to leave me a follow if you are interested in that. But now let's jump right into our topic. As I promised, I want to lead you through some kind of a process, through various steps. And the first step that we need to talk about is step 0. Oh no, do we really need yet another framework? I guess many of you have already heard the term framework fatigue, because in the JavaScript, in the web world, you just turn around once, look back on the screen, and yet another framework has appeared. Luckily, this has slowed down a bit, but we are here today because there's yet another contender that is worthy to talk about. But the question is, why do we really need a new or another framework? Before we're going to talk about that, let's take a look at this demo application. So we have this application. All these little boxes are components in our application. So we have this app component. Probably every framework in the world has a top-level app component or a page or a root or whatever. And inside of that app component, we are rendering this GitHub checker, a header component, a username form, a main component, etc., etc. Of course, we build web applications with frameworks because we don't only have static sites, but we have interactivity. So for example, in our application, we have this username form where users can enter a GitHub username and then want to search information, search the repositories of their user, and display that in the user interface. So right now we have the source of the state inside of that username form component. So for example, in the Angular world, you'd have a component, a class component, and have an instance field. In the React world, you'd have a useState. In Vue, you have a data prop, etc., etc., etc. But now, of course, we don't only want to use this piece of state, this piece of data inside of the username form, but also in the user details and in the user repositories component, because we need to fetch data, we need to display the data, we want to display the current username and stuff like that. For that, luckily, most frameworks agree on how to approach this kind of communication between sibling components. And the solution is to just pull the state up to the GitHub checker component. So we are pulling state up to the first parent component over all components that need this piece of data. So now the definition of the state is living in the GitHub checker component. And whenever we want to change this piece of data from the username form, so we still have this input rendered there, for example, and whenever a user types there, then we update the state in our GitHub checker component and can propagate the changes through our application. And this is where it gets really interesting. Let's first take a look at Angular. Angular has a concept, and that's called change detection. It can have multiple modes, and it's the process of how Angular can know which parts of the user interface needs to be updated. And Angular, per default, is using a quite simple strategy. It just runs the change detection for all currently rendered components. Change detection means Angular goes through the template and checks all dynamic slots. So whenever we do some interpolation, use dynamic data from JavaScript or something like that, Angular iterates through all those dynamic slots and compares if something changed. And when something changed, the DOM, the browser interface, is updated. So Angular does this for all components that are currently visible in our application. This is quite nice for us as developers because we never have to worry about stale data, because when everything that is currently visible is checked, then everything will always be up to date and there will be no issues. But of course, this is quite a bit of work, and when you have a large page, a large application, then maybe you are rendering many components inside of the user interface, and the change detection will definitely begin to slow down your application. The React world, on the other hand, is a bit more restrictive. React wants us to live top-down data flow. So React expects that data will always travel from top to bottom, never the other way around. That way, React can make the assumption that only components need updates that are below the component that defined the state. So in our example, the GitHub checker component defines the state is changing, so only the yellow marked components are going to re-render. So again, in the React world, re-render means execute our function components or execute the render function of the class components, create a new tree of JSX nodes, compare the JSX nodes, and when it finds differences, then React will update the DOM. So like that, we skipped the re-rendering for the app component and the hamburger menu because they don't really have anything to do with our little state that we changed right now. But this is still not optimal because, for example, the footer component also doesn't have anything to do with the state, but is still re-rendered. Of course, there are certain methods and techniques to improve that. You can use React.memo or React.useMemo to improve the rendering of our components, and by that we can skip components that really don't have anything to do with our state that is changing. But as we're doing right here, we are still passing the data down through props, so the intermediate component, the header component, and the main component still have to re-render, even if they don't really display the data, they just pass it down to their child components. So still not optimal. The Angular world has such optimizations as well. On their part, you can change the change detection strategy from default to on push, and you can even do a bit more optimizations, which can result in an application where only the components need to run the change detection where the data is really being displayed. So the GitHub checker, since it's not displayed there, it's just holding the state. For example, it's holding the subject, the RX observable. It doesn't need to re-render because it's not using it in the template, and the observable, the container that contains the changed value, will just be propagated down through the tree, and our low-level components will subscribe to the data and will do the change detection on change. This is already quite good because, of course, all of you are writing really small components, like 5 lines, 10 lines, something like that. So whenever one component updates as a whole unit, it's not a problem because components are really small in practice. Right? In my experience, this is sadly not really true. So I've worked in many different code bases, and of course something like this happens. So we have a form component, a sign-up form where users have to enter fields upon fields upon fields. The product manager is already not knowing where to put more fields on the screen because the screen is so full, and you end up with a component that is hundreds upon hundreds of lines of code. And of course, when you now do the change detection on a component level, you still have to do lots and lots of work, even if you use the state only in one small part of your component. So there's still lots and lots to do better in our applications. In theory, what theoretically would be possible is that we should, in theory, know where our piece of state is used in the user interface so that we can directly update these places in the user interface and nothing else, because our change originates from a change. So we have an event that changes our state, and then why do some more diffing? Because we know something changed and now let's update it. So in a perfect world, all that is executed when something changes is such a little function that gets the new value and places the new value in the DOM where it's currently displayed. So for example, like this, we are setting the text content property. It's just a simple DOM property that the browser gives us to change the text of an HTML element. So in a perfect world, this would happen when we change some piece of state and nothing else. No diffing, no comparisons, no change detection, no manual annotation of where change detection should run, no manual optimizations required. And this is exactly what Solid promises us. And this leads us directly to step 1. This looks just like React. And for that, we are going to jump into our demonstration. So right here on the left, we see the browser where we rendered our application. On the right, we have Visual Studio Code open where we built our application. In the background, there's the Vite process running that is watching our files, compiling the code, outputting it, yada, 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 as you know it from other frameworks as well. So on the right, we can see our app component. Let's add a couple more exclamation marks. And you can see we update on the right, it updates on the left, and it's just like React. So we are using JSX, we are even using TypeScript, so TSX files, and have all the support that the community has built around JSX as a tooling framework. This also works with subcomponents. So let's add another component. Here we add a main element where we add the heading. Let's pull that down from here. Let's add the heading here, and maybe let's add some content as well here, and let's use the main component. And here we can see it just works as in React. It's looking the same. It's basically the same thing. You have data that is displayed there. It's quite boring even. But of course, we don't only want to render static pages. We only want to have dynamic data. So we need to pass down data through our components. So maybe let's add the heading or some kind of title right here. And again, just like we are doing it in React, let's add the title here, props.title. And since we're using TypeScript, we get the help right here. And add it right here. And in the user interface, of course, nothing changes. But really to nail it home, it's basically the same thing as React on the basics. Now maybe let's add some bit of some interactivity right here. So let's add a button here. And even that works just like in React. So let's do an on-click. And pass in the on-click function from the props. And now, of course, we have to define it up here. On-click is console.log hello. Now we have our button which says hello world. We are passing down the on-click function. And when we click the button in the user interface, then we get this hello on the component. Again, just like in React. Quite simple. But now we already can see, we have this button looks kind of ugly. It's unstyled. This is because I have Tailwind included inside of this project. So same thing as other frameworks, Solid does not bring its own UI components. It just gives us access to the DOM components. And because we're using Tailwind, all styles are basically removed from the button. So let's add some of our own. So let's say we add a class. Add a pink background, and let's add a padding, something like that. And let's make it rounded as well, like that. And now we have our round button. And if you have been very attentive, then you can see that we just spotted step 2 of our presentation of our stages. This is a nice improvement. In Solid.js, you can just write class. No more class name, no more HTML4. You can just use all HTML attributes that the browser understands in HTML and can use them directly in Solid. Many of the attributes are mirrored again, so if you're copying stuff from the background, much of the stuff works. But the basic stuff, TypeScript, for example, as well, is complaining about class name. But just using class is just working, and it's a nice improvement because we don't really have to care about the difference between React and the basic HTML, which is always in trainings or coachings. It's always a problem when people first learn React, where they stumble upon the first couple of hours. So now we have some nice improvements upon React, for example, but other than that, is that really enough reason to build a new framework? And this leads us to step 3. Wait, how? And for that, we are first going to introduce some state in our application that really changes. So for example, let's go in our main component and add the typical counter. Count, set count, create signal. So instead of using useState, we are using createSignal, just another name for the same thing. It's a piece of state that changes across the lifecycle of the component. And now let's display that, count. And whenever we click on the button, we call setCount and increment the counter. So just like in React, we can pass this function callback where we take the current count and calculate the new count, a new state, and update it in the user interface. So when I press right here, the user interface updates. Great. Really nothing has changed in comparison to the React alternative. But now let's try to add a console log right here. No, let's say hello from main component. Now we can see on the initial render, we log it on the console here, we can see hello from main component. And now, of course, since we are React developers, whenever we click on the button, we can see that is again, oh no, it isn't. And here we can see the great difference between Solid and React. Our console log statement within our component is only executed once when the component is first instantiated on the screen. Of course, when we have multiple instances, when we render the component twice, for example, then we would have seen it twice, but the state changes do not impact the code that is in your component in any way whatsoever. This makes lots of things a bit more easier because you can really start fetching data in here. You can start timeouts in here. You can worry about much less because the body of your component will only ever run once. This also works when we pull the state up into a parent component. So let's pull it up here. Let's say we want a count, which is a number here. There we pass in the count, and we have to add those mysterious brackets. We will take a look at that just in a second. And of course, we have to render props.count and props.onClick. Let's revert that so that on click, the outside world, the outside component is defining what should happen. And let's here set count. Let's do it like that. So again, we have the state up here in our top level component, and inside of the child component, we are using this state in the user interface. And whenever we click, we updated it at the top again, and hopefully the user interface updates. So we click on the button, the user interface updates, but our console log statement is never executed again. So you can really be sure that statements that are directly within your function component inside of the function body will only execute just once whenever we instantiate the component. The cool thing is that this also works when we pull out the state. So let's revert that again. Let's remove the count. Let's remove the onClick. And let's move the state back inside of the component. Count, set count, count plus 1. Okay, of course, we need those brackets here. So it's still working. Now let's render the main component twice. Let's add a div here as a wrapper element. Let's render the main element once and render it twice. And remove the semicolon. So as I just said, the console log, the body of our component will execute once for each instance of the component. So we have the component twice right here, so it's logged twice to the console. Whenever we click on one component, its counter is incremented. Whenever we click on the other component tree, then this button is incremented. If we wanted to synchronize those two buttons, in the React world, we'd have to introduce some kind of state management library, pull in Redux, Zustand, whatever, or pull the state up into another component. In the Solid world, this is a bit more simple. We can just pull this line out of the component function, reload our page, and our states are synchronized. So now we have one application-wide state that is shared by all components that access the state directly. We can even go one step further and take that and pull it into another file, count.ts. Of course, we need to import this function, export our count and the setCount function. Let's remove that. Let's add some more imports for the count and for the setCount. So now our state comes from this other module, is imported and used inside of the component, and set from our component as well. And again, we reload the page, click on the button, and our states are synchronized. So now all components in the application could import this global state in our application, and we have introduced a small little global state utility that can just be set from anywhere. Of course, this doesn't mean that you should do this, but it's possible to pull the states out of a component because these signals, they live independently from the component, and the component just connects to the signals. So because I really dislike global state in applications, let's remove this again, remove the imports and add that again. So now we have again this behavior. Maybe let's remove one app because we don't really need that anymore. We again have this behavior that we are logging at once to the component, and nothing happens when we on the console. Nothing happens when we change the state, but our content in the user interface is updated. So when we now try to log the current value to the console, you can see the current count is logged to the console, 0, but as we click, nothing happens again. Because again, just to hammer it down, the body of your component is not reactive. So whatever happens up here, it happens once per component instance and then never again. Whenever we want it to happen again, we can use a function called createEffect. And again, if you're a React developer, then this might sound a little bit familiar with one small benefit, that in createEffect, you don't need to track dependencies manually. So you can see whenever we click the button, we now get the console log again, but we don't have to track dependencies. If we had another state right here, so for example, let's log props.title, we also have the guarantee that this console log will always fire when props.title changes. Solid is doing this completely at runtime. So while something like Svelte checks your templates at compile time, checks where you use which variables, Solid does this at runtime and is thus much more stable and much more robust. So Solid does it like this. Whenever a component mounts, it executes this function once, because initially an effect always has to fire, just like in React as well. While this effect is executed, Solid checks which signals are read within this effect. So right here, we are reading props.title. This is just a small redirect to the title property up here, which never changes. Maybe let's do it like this again, that we log the count. Now we get the console log again. So on the initial run, or on each run, Solid will check which signals are read within the effect and register that effect as a dependency. So from that point in time, Solid knows that whenever someone changes the count, so whenever someone calls setCount with a new value, then this function has to be called and nothing else, when we don't use the value anywhere else. So of course, you can have multiple effects that then have to be executed. But by doing that at runtime, Solid knows for sure which pieces of code need to execute whenever a signal changes. So when that signal changes, this function needs to be executed and this needs to be replaced. The same thing can be done with styles, for example. So let's add an inline style right here. And let's say position relative, top. And just let's move the heading down whenever we click on the button. So we move it a few pixels down, 1 pixel per click, so that we can see that something is happening. Now let's take a look at the compiled output from Solid. I have disabled the source maps in my browser, so don't worry, because normally source maps are enabled and you would see the same thing as on the right. I disabled it for now. And now let's take a look at the output of our component. And the nice thing is that it's basically the same thing as we have written on the right. It's a bit more verbose, but it's nothing compared to the output of this Felt compiler, for example, because much more is done at runtime. So right here, we can see our main component that is adding this create effect. In here, inside of the JSX part, this template element is cloned. Let's check where this is defined. It's up here. And you can see outside of our components, all static parts of our interface. So the main element is completely static, nothing changes on there. The H1 is static, the H1 hello part, completely static, nothing changes there. So the Solid compiler will pull that out inside of this template expression, which will create an HTML template element at runtime. Template elements are part of the browser API and are made so that updates or creations of this template are much more performant than doing create element or something like that. So you can just say template clone node and get a new instance of these DOM nodes that are statically described in this template. So we have all the static parts inside of these element variables. So we are just doing template element clone node for the top level element and then accessing some child nodes in there to gain access to all dynamic nodes. And now let's check what's happening with our top property right here. So we can see Solid is compiling our attribute in here on the right and compiling it to an effect call. And whenever, it's basically the same thing as the create effect here up top, whenever a signal changes that is used inside of that effect, this line of code is executed again. So we can see whenever the count changes, this line is directly executed. So it's basically the same thing as you would have handwritten this dependency by yourself. So whenever the count changes, then we want to set style on this element. And Solid is doing that basically automatically for you. Because again, Solid can check whenever we execute this, which signals were read, and know that whenever the count signal changes, this line of this function needs to be re-executed and nothing else when the count is only used there. So right here you can see performance is just handled for you, because of course in React you can do this as well, that with memos you can add memos so that React is doing less and less work whenever something changes, but you have to do this work manually. In Solid this is all done for you so that you don't have to really worry about that. And to demonstrate this a bit more, let's move that inside of a component again. To demonstrate this a bit more, let me show you another example. Let's remove some code here that we don't need for this example application. And now let's add something up here. Let's add two signals for an x coordinate and the y coordinate. So x, set x equal to create signal. The same thing for a y coordinate. And now we want to track the mouse position on the page, on the web page. So we need a function on mouse move. We can add a listener document, add event listener, mouse move, on mouse move. Let's get a bit more room here. And of course we want to clean up that. Like that. And let's remove the event listener again. So again, another difference to React, because we know that this component will only execute once on creation, we can just add the side effects or the add event listener inside of our component. Of course, this assumes that we are running on the client side. So when you're doing server-side rendering, which Solid supports as well, then you should still put that inside of an effect as in React. But when you're sure that you're doing client-side rendering, you can just place that within your component body and be sure that this function is only added once as an event listener. So whenever we move the mouse, we want to set x with e.clientx and set y e.clientY. So now we have those signals that are tracking the current mouse position. Now let's hand those down into our application. X number, Y number. And let's add an element right here. Maybe with an emoji in there, a finger emoji. And let's say position fixed. Top is props.y plus pixel. And left is props.x plus Of course, you could also do this with the transform translate to make it even more performant, but we will just keep it simple right here. And now we need to pass in the x and the y value, x, y. And now we have our cursor that directly tracks the mouse position. And we have defined the state for this cursor at the top level of our application. Again, we could even pull it out of our application and make it available for everyone, for every component inside of our app, and still have the same performance characteristics. So we have these signals right here. They are set from the mouse move. So whenever someone moves the mouse on the page, we are setting those signals. And now Solid knows where those signals are used. And the only place where those signals are really used is down here. So the only thing that Solid will do when we move the mouse is call style.top is equal to props.y. So the only thing that happens is the direct DOM update that needs to happen whenever our y coordinate changes. Nothing else happens in the user interface. You don't even have to worry about this one bit. So no more use memos or create memos or react.memo. Really not needed because Solid tracks where our values are used automatically. And now let's do one more enhancement just to have a bit of fun. Let's call it x spring is create. Spring is just a function that I implemented where we can pass in our current x value, where we can pass in the current y value. And let's replace that here and here with x spring and y spring. And now let's see how the cursor is jumping around with a cute little physics animation. And again, this animation is completely tracked by the main state primitive of our framework, createSignal. In a React world, this would be completely unimaginable. When we take, for example, the documentation of React 3 Fiber, at the very top of the performance pitfalls section, it says avoid set state in loops. Set state in React is not suitable for fast updates. So for example, when you're animating something, it has to update 60 times per second. And React's reconciliation process is just not really made to be called 60 times per second, especially when you're updating a state that lives on the top level of your application. So for example, if you have a React context, pass values down, whenever this context changes, everything updates, and you get massive performance problems when you do this quickly. In Solid, this is just really not a problem. You define your state variables, you pass them down where you need them, and every location in your code that really accesses those state variables will know that it has to update, it has to rerun, and nothing else. So again, let's just add, to demonstrate this, a console log here. And we should be able to see that this is only ever logged once. It doesn't matter if a signal changes, if our count changes, it just works, it just updates, it just logs to the console once, and nothing is rerun that is not really needed to rerun. I hope these two examples could showcase a bit how Solid is really a bit different than other frameworks, because this performance part, it's just, you don't have to worry about it, it just works when you keep the reactivity through your whole application. Now let's go into a bit more detail. So now we are entering step 4. I'm sold, please tell me more. Let's jump into a bit more, some benchmarks and metrics, because numbers are fun. We have talked a lot about the runtime performance, but before we go into numbers there, let's first talk about the bundle size performance, because of course, when you're running JavaScript code, the user first has to download all that code inside of their browser so that it can run. Here you can see the framework bundle sizes, so it's just the bundle size of the framework part, the fixed part that you always have to add to your application whenever you need at least one component of the given framework. This is the compressed size, and here you can see Svelte, the king of compilers, so to say, at just below 2 kilobytes, is still a large chunk smaller than the Solid variant with 4 kilobytes, but both of those are really in another ballpark than the React variants, or do the same thing with the Angular variants, for example. So you can see even if Solid is way more performant at runtime, it's even also small on the bundle size part. But this is only the bundle size of the vendor chunk, because of course you're not only shipping the library to your clients, but also your application code. And for that, we have to look at how the bundle size progresses when you add more and more components. On this chart, you can see on the left the total bundle size of an application on the y-axis, and on the x-axis, you can see the count of to-do applications that are bundled inside of one large bundle. This is to simulate an application that gets larger and larger and larger with idiomatic components in the framework. So this example is just taking the official to-do MVC implementation of the given framework and bundling that 10 times, 20 times, 30 times, etc. Here you can see that Solid and Svelte start really in another ballpark than the React variant that starts at right below 40 kilobytes when you're building one React to-do application. But you can also see that the slope of our lines is quite different. So for example, the Svelte line, because much of the logic of the framework is compiled inside of your components so that you don't really have much runtime code. This is why you only get 2 kilobytes of library code, because everything else is just compiled inside of your components. That means each component gets quite a bit larger, so the slope is steeper. That is, in practice, it's for Svelte, it's not really a problem, because having, as you can see here, we only crossed the React boundary at something like around like 50 to-do applications, and having 50 to-do applications worth of code inside of one chunk, inside of one bundle, is really not the best thing anyways. So maybe you should think about code splitting and stuff like that so that you don't have one larger bundle. But you can really see in the left part of the chart that when you want to build applications with a very low bundle size, then Solid and Svelte really are just the better choice, because they give you so much more headroom to build stuff before you reach your bundle size threshold. Just to make this more clear or more palpable, when you can build 25 Solid to-do applications with the same bundle size as you would have needed for one React to-do application. So when you're building one application, when you're building an application with only small parts of interactivity, you have so much more headroom when you're picking one framework with a very low library bundle size instead of a framework that has a larger bundle size to begin with. That's the bundle size point of view. Now let's go back into the runtime performance of the different libraries. Here we have the geometric mean of the JS framework benchmark. You can check that out on GitHub. You can make contributions to the different frameworks to try to improve their performance metrics. And you can see on the left the vanilla JS implementation. That's just the baseline. So it's just the most performant, most optimal implementation of the benchmarks. It's just a table application that updates many cells multiple times per second and measures how quickly that is working. And the vanilla JS implementation is hundreds of lines of hand-optimized JavaScript code that does all operations as fast as humanly possible, or as browserly possible, so to say. And so that is the baseline with 100%. And you can see right next to that Solid.js at 105%. So it's just 5% slower, but it's something like 80 or 90 lines of code of idiomatic, easy to understand code, because it's just using components. It's just using signals that update other signals and update the user interface. And if you look all the way to the right, you can see the React framework, which is almost twice as slow as the vanilla JS variant, while still having while still being quite concise, because you're still using the idiomatic React approach, but you're as a trade-off, you are losing lots and lots of performance. So am I here to tell you that Solid.js is the perfect framework? Of course not. Let's talk a bit about what Solid.js cannot yet do, because Solid.js is developing really in the right directions. When you have a web application, oftentimes you have those two worlds of your data tree on the left and the user interface tree on the right. So for example, you're downloading a list of users from GitHub, for example, and for each user, you're going to display a list element, so a piece of UI for each user. Inside of each user, you have a name field, and this is displayed inside of a p tag inside of the list element. So for each user, you have a name on the left on the data side, and on the right, you have the list element and a piece of content. So what Solid.js tries to do is to map those two trees as fine-grained as possible. So whenever one piece of data changes on the left, we only want to update the corresponding piece of UI on the right. And Solid is really, really good at it. But that also means when you completely exchange the data, you get a completely new user interface tree. So, for example, you just refetch the GitHub users, put them in a signal. Solid will see a completely new data tree, remove the old user interface tree, and build up a new user interface tree, which is normally not a problem because it's fast enough to do that. But of course, this can introduce problems like you're using state in your components, or when you have an input inside of the list items, for example, for whatever reason, then these inputs lose their state because they're completely rebuilt from scratch. Of course, there are utilities to mitigate that problem. So Solid tries to, whenever you fetch new data, you will just merge this new data into the old data. So you keep everything that you had previously and update it with the new information that you retrieved from the server. So really not a problem there, but this is something that you need to keep aware of, that whenever you completely exchange pieces of data, then the corresponding pieces of UI will also completely be rebuilt. Next, we need this reactivity to keep the great performance of Solid, but this also means that we have to maintain the reactivity, and this chain can be broken. This can happen especially when you're coming from the React world and use certain patterns that are quite common in the React land. For example, let's go to our main component and do something that is done in quite a lot of React applications. Let's use destructuring right here, and let's get the X prop from the props. Of course, I could also get Y in title, but we will just do X for now, just to showcase it. Now, when we use the variable right here, we can see that our mouse cursor, the pointer, is no longer moving from left and right. So the X coordinate is stuck at the first value. This is happening because, as I said earlier, or as I said multiple times already, the body of your component function is only executed once on the mount of the component. It's just like a constructor function. So when we are constructing the main component, we are looking inside of the props and accessing the current X value, because it's just a number and it's a constant. We can even log that, console.log X, and we get the 0, the initial value, directly on the console. And since it's a constant, it can never update ever again. It's just a number that sits there in memory and will never update. So when you're doing destructuring, you just kill the reactivity, you kill the link between reading our data and the signal where the data is defined, because we already pulled the data out in a place where we don't have any reactivity. We just have a function that is executed once. When you really want these extra variables, you can pull them out with functions. So you can say x is props.x, and then you have to call x down here, and then it's working again, because now we have to we kept the link, the reactivity chain intact. So we have the x right here. So Solid in the effect will call this function, the x function. We jump in here, we check the getter on side of the props value. At compile time or at runtime, this will be compiled into a getter call. Maybe let's just take a look at that. So here we are creating the component. The compiler is translating the JSX part into this create component call. And here you can see the X property is transformed into a getter. It's just a function that is executed whenever someone accesses this value, this property. So let's go through the chain again. Inside of the effect here that updates the left property, the X value is read, so this function is called. This calls the getter inside of props.x. This calls the getter in here, and this getter directly reads from the signal. So we have this chain of reactivity intact all the way from the place where we're using it to the place where it's defined, so that Solid knows that whenever the definition changes, then it needs to re-update this piece of code. And here we can see that the cursor is moving again. But this is something that you really need to be aware of, especially when you're coming from React, because it's just turned into muscle memory that you are using destructuring, or that you are just getting values from props and putting it somewhere. And this, as we just saw, will just kill the reactivity in your application and will just cut the chain and freeze your values in time. And point 3, I'm happy that David has joined us already, because this is in a large part his responsibility. The community at the moment is still quite small, but as we just to look a bit forward one slide, the community is making huge steps forward on that regard. So when we zoom out and compare React, Solid, and Svelte, you can see React is just in another dimension because everyone is using React. Every large company is using React. Svelte is something around 300,000, Solid at 30,000 downloads per week. So we can see Solid is at the moment still quite small. This is on the one hand the user base, people that use Solid, that also affects the job market, of course, that affects component libraries. So it's just still a very small ecosystem. But as you can see, when we only showcase the Solid.js numbers, we can see that it really only started in 2021 with real usage, and the direction is definitely the right one because maybe when you check Twitter and search for Solid, you can see person after person after person trying out Solid and telling you this is great, this is something new, this is something that why have we been using React for so long when something like this can exist, when something like this is possible. So I definitely see the future of Solid definitely going into the right direction and the graph going more and more upwards. We had a large community event at the beginning of the year where many people built new libraries. So we in the meantime, we have libraries like Solid Bootstrap, Hope UI, libraries component libraries that are accessible so that you can get started quickly with your applications. And most of the time, porting code from React to Solid is quite easy because it's the base structure of a component is quite similar. It just gets, when it gets to the reactivity, to the data part, then you have to be a bit more careful. So as you can see, the community is definitely going in the right direction, and this is where you come in. Because right now I told you a bit about Solid, and that is the best thing ever, and you definitely have to try it, especially when you're having performance problems in your applications. But now, of course, the question is, how can you become part of the community? For that, I will give you 3 links. The first one, the Discord. We are just such a very cool community. There's a help channel where you get help in something like 30 minutes when you need something, when something is not working. Especially when you're in the early stages of getting to know Solid, when you have some beginner questions, I think you will get the answer in like 2 minutes because people will just jump on your question and help you out because the community is just so friendly to each other. There are regular community events where we talk about the direction of the framework, the direction of meta frameworks like Solid Start. So when you want to take part in the community, it's completely open. Just join the Discord and take part, ask your questions, and share your opinion. Next, when you just want to try out Solid, just check out the website. There is a beautiful made tutorial that leads you through the different stages, the different concepts. It introduces you to the signals, to effects, to loops, and stuff like that. Many of the different intricacies and the differences between React and between Solid and other frameworks are showcased there. So just check that out, play around a bit. It takes something like 30 minutes, I think, and then you can get quite a good feeling for Solid, I think. And lastly, if you want to take a look behind the curtains, then I highly recommend Ryan's blog post. Ryan is the creator of Solid, and he has really written in-depth posts about creating a new reactive library that is trimmed for performance. So if you're wondering how they are doing it internally, just check those articles out. He's comparing multiple frameworks or multiple approaches of different frameworks. So really a great resource to jump into that. And this leads us to the end of our presentation. As I said earlier, we at my company, we like to accelerate your projects, and maybe Solid is just that, the library that helps you to get a grasp on your performance in your applications yourself. If you're interested in those kind of topics, just follow me on Twitter. I post regularly on some kind of web development, TypeScript, React, Solid.js stuff. And I hope that you have some more questions now for now, because it has been quite quiet in the chat, so that we can play around a bit more, because this for now is the end of my presentation. And if there are no questions, then again, thanks for watching and thanks for tuning in. And now let's see if someone has questions. Again, we have to wait a bit because the stream is a bit delayed. We have to see if there are any questions that pop up. In the meantime, I will just show you that when you're activating the source maps, then it just looks like your regular old code in the browser, because the source maps just work and show everything from your editor without any problem. So you don't have to take a look at the compiler output. But as we maybe saw, it's quite useful to check out how Solid is doing something behind the scenes. Any questions? None so far. As I said earlier, maybe I can show you that. Maybe it's interesting for you. It's just using Vite as a default bundler where you have the Solid.js plugin. I disabled hot module reloading just for the demonstration so that everything is cleaned up properly by reloading the page. So you can see it's using a modern bundler, a very performant bundler, so the developer experience is really excellent when using Solid. You have this declarative approach of React while still keeping the best possible performance, so to say, because as we remember, we only lose 5% to the hand-tuned vanilla.js example. Okay, it seems like there are no questions. Then all that's left to say is thanks a lot for tuning in. Oh, okay. One question is in the chat. Maybe we can take a look at that. Let's take a look at the performance diagrams. No, right direction. Here, how would you compare? It really depends on the version. Let's check that out. GitHub JS Framework benchmark. Let's check out where is the link. Official results page. Here it is. Let's go to the newest version and let's select Vue 3, the newest Vue version. Svelte, Solid, and maybe let's check React and Angular. Oh, interesting. The React 18 version there's no React 18 version so far as I can see. And where is Angular? Angular v13 here. So we've earlier we checked out the geometric mean here, this row, where you can see the Solid variant. It got even faster. Wait, let's add vanilla.js back to the mix. Yeah, you can see. Okay, Solid is so it seems like vanilla.js has improved a bit. Solid.js with 1.07. Maybe let's zoom in a bit more. The React hook version is the best one. Thanks, Ryan. Here, that's also on. That's additionally on React 18. Perfect. So as we can see here, vanilla.js on 100% 1.0, Solid on 1.07, and here you can see Vue is definitely in the right direction. And here React and Angular. Okay, so the numbers in my charts, I can update them as well, them a bit. That React has gotten a bit closer to the vanilla.js implementation, but it's still quite far away. Are there Redux hooks like useSelector for Solid? I don't think there are they are complete libraries for Redux, but as I said, writing those bindings or porting the bindings from React or from other frameworks is quite easy in Solid because you are just using the same basic principles as in React and just use other hooks. But one very important part about Redux is basically very much invested in the immutable word. Since in a Redux store, you will oftentimes replace data completely, which will lead to replacing the interfaces in your applications. So there you have to switch around a bit in your approach because you could degrade your performance by just putting the Redux data in your components, because Redux, as I said, will oftentimes recreate objects. When a field changes, for example, it's a completely new user. So the user component will just completely unmount and remount. So I think Redux might not be the best possible approach for the Redux world, but you can definitely easily build something like that for yourself. So Solid has a utility that is named create store. Set store is create store. No, I have to import that manually once. Whoops. Solid store. And now we can import create store. And maybe let's say we have a list of users that have some fields, something like that, name, string. And then you can have this global store in your application Okay, that's of course yes, like that. And now you have your global store in the application, can use that in all of your applications. So you don't really need use selector because you can just access the data directly and have the same result, because components will only recalculate, or effects will only recalculate when the used piece of data changes. So use selector is basically useless. So you don't need that when you're working with Solid. And then you only need to add this reducer pattern, where you can just build your own infrastructure for that, for a reducer, where you define some actions. So a dispatch function that gets some action type, whatever, and write your reducer that just changes the store and calls functions on the store to update the data. So you can really easily rebuild the stuff, because the state solutions that are built into Solid are really a bit more powerful than what React gives you. So there's not much need to use external state management solutions. Yeah, so maybe let's demonstrate that. So let's add a count right here, count number. So let's start with 10. Let's add that inside of our component. We could of course put the store into a context and provide the context through the application, but we can also just directly use the value. So store.count. Now let's put the store and the set store on the window object, so that we can access it from the console. Store, set store, like that. Let's go into the console. Let's check the store out, where here we can see the store is there. And now let's add set store count 20. And as soon as we call that, this is updated. So we don't really need a hook to connect the store to the component to the store, because it's just tracked at runtime. Because again, where did I use it? Here. For that piece of code, for that curly brace, for that dynamic expression, an effect is created. So this effect is run on the first mount for the first time. In there, the count variable is read, and thus Solid knows that whenever the count field changes inside of that store, then this component needs to update. And again, we have the automatic best possible performance. Whenever we set the value, this is the only piece of code that updates. No console logs, no re-renders. So this is not run. Nothing else happens except that this is replaced in the user interface. Next question was how is the reception for Solid in Germany? I have given a couple of talks on German conferences so far, and everyone that I showed this to, or everyone that saw Solid.js, is really hyped about that, because it's just, for the developer, it's a lot like React, so you feel right at home. But this whole chunk of space in your mind that you have reserved for performance, for hooks, for dependencies, for manual dependency tracking, for closures inside of your React hooks, it's just free to wonder about anything else when you're using Solid. So far, I've been working with 2 companies where we are using Solid in real-world projects, but you have to be honest there. The community ecosystem is just not as large. So, for example, in another project, we had the goal to build really a proof of concept, a prototype within 3 months, and there we didn't want to spend any time building our own date picker, but we wanted a nice date picker for our users. So we chose React, so that we have a larger amount of component libraries that we could choose from. But as I said earlier, Solid is definitely going in the right direction on that front. So we will just have to wait a bit in projects when you really depend on external projects. The more long-term your project is set up for, the more reason there is to use Solid, in my opinion, because when you're really working on a project for like 5 years, then building a date picker in a week, or maybe in 2 weeks even, is just a good investment, so that you can use Solid in your application and maintain the performance across the whole lifespan of the application. Okay, I think that were all questions. Let me just put some links into the chat to the framework benchmark, for example, if you want to check that one out. And again, as I showed in the presentation, if this is in any way interesting to you, just check out the blog, check out the community pages. One more question. Are you familiar with style components? Yeah, I am. I think using Tailwind is, I'd say, a bit more on the rise. I'd like to say, in comparison to style components. I'm not sure if Solid has bindings for emotion. I'm pretty sure it doesn't have bindings for emotion. I think there are bindings because they are actually quite simple to use. So this looks like it exists. I'm not quite sure it has 1,400. It's by Ryan itself. So I think you can say that this should be working. So you can use style components if you really want that. But again, in our projects, in one project we picked vanilla.js, vanilla extract, which is a CSS in JavaScript, or CSS, yeah, of course, perfect library name. We picked vanilla extract, which is a library that statically extracts your styles into style sheets at compile time, so that at runtime you only have the style sheets available, and you have a type safe interface for your variables, so that you can get dynamic data inside of there. And we used that in one project without any problem. As I said, we used Tailwind, and as you can see, style components, there also exists a repository for that. Maybe we can check out the issues. Yeah, you can see it only has 20 issues across the lifetime, so it's still quite new. So you have to see if that really is working or not. You have to try that out. But thanks for the question. Any other questions? So for me, it started with just, when I started Solid, I just picked something like that, where I built something that really makes use of the reactivity of the framework. And it was so much fun because you don't really have to worry about anything. In the Solid, in the beginning of the year, we had this hackathon, Solid Data Grid, where we built a data grid with Solid.js, where we built a very large grid with, as you can see, 100,000 rows, 100 columns, and it's just buttery smooth. And during developing that, we really didn't have to take any. We didn't have to be cautious with regards to performance. And when we built this more or less the same grid inside of React, it really was a hustle to keep the changes local, so that not too much is re-rendering in the user interface. So just another use case that really showcases that you don't really have to worry about performance when building with Solid. Okay, since there are no more questions left, again, I'd like to thank you for tuning in. Feel free to check out the meetup page of the Way Forward meetup, and check out the upcoming topics. And I hope I will see you at another meetup or at a conference in Germany. And I wish you a very well evening.